So good afternoon and welcome to the Network Management Operations, the NMOP working group. I'm Benoit. We have met, and the third chair, Richard, who should be joining soon remotely. So the note, well, it's a second meeting, but I want to repeat a few things anyway. So by participating in the IETF, you agree to follow the IETF process. There are a couple of references there that you want to read. And basically, a key message from me is that anything you say during the IETF meeting is a contribution and should be considered so. Note very well that we'd like to promote a professional environment here. And this is how this meeting is going to be run in a professional manner, respect each other. If you believe for any reason this is not the case, there is a process here and some RFC and a process to follow to report any issues. The tips to present, to ask questions, you need to log the data tracker. There are like QR codes over there. It's specifically important for people remotely. They need to log in to be able to share. Join the microphone queue so that we all see your name. It's easier also for the meeting minutes. And for the remote participant, it's always better to get a headset. This is the second NMOP session. Since a few meetings, that's what we do, a second session is focused mainly on the hackathon results. There is a small exception here with the network anomaly draft that will be presented part of the hackathon. Now, in the agenda, first, Thomas is going to report on the result from the hackathon on configure subscription, Yang push publisher. We will also have by Sheriff reports on the CMAP for SRv6 and linking topology to external data. Vincenzo will speak about the anomaly detection integration updates. And Michael will speak about his work from the Yang configuration instance data to knowledge graph. Before we do the agenda bashing, I want to go to the next slide because if we have time, we've got a bunch of very interesting students coming to the hackathon who've been implementing HTTPS. They've been presenting in NetCom just right now, but this is typically the type of things we want to promote. So if time allows, we're going to give them the floor to advertise their work. Remember, NMOP is about experiment, IETF, consensus, and running code, so that's exactly what you want to promote. So any agenda bashing? Yes, Adrian.
Yeah, not really an agenda bash. I'm Adrian. In the first meeting, I said I was going to get with Rob and talk about the progress of the terminology draft and his review. We did that. I think we understand where each other are coming from. I will be making some minor edits to make the definitions more precise. And I'll also be doing a more detailed survey of the existing NMOP drafts and the way they use terminology. And I've started that, and the first one's just hit the list. So everybody should expect that, but I think that will help us plow through this.
Thank you very much. And we've got like the last call review comment even before last call. Thank you very much. So the first presentation is from Thomas on the result of the hackathon on Yang push.
Good. Let's see. Yeah, so we have been steadily testing Yang push publisher implementations as we are progressing with several draft updates. And this time our main focus was on the last two adopted documents at NetConf on the notification envelope and also on the systems and notifications capability discovery. However, we have also one more news is that so far we have been testing this on routers. Now also we are arriving at broadband access on an OLT, on an another news we have is we started to create a little website here, should help a little bit to get implementers better around what kind of specifications they should implement, what are existing implementations, and also which are the RPC calls, how to deploy, and also what are the latest changes in that area. We put everything in one GitHub repository, so you can find basically all the test results in there, the configurations we deployed, the captures we took on the Yang push receiver, and also after the data collection and transformations. As I said, main focus is the capabilities discovery, the envelope, and also small news we had is we had the first CBOR named identifier implementation. That's an example message from Cisco iOS 6R. I marked just yellow the changes to the previous release we had at IETF 121. So you can see the library, the Yang library content ID, the subscription started, and the envelope notification header. Then here another example, also from Cisco iOS 6R on the Yang push capabilities. The part where we discover the envelope is supported and also the transport support. Then on the Huawei OLT, the subscription started and also the initial on-change sync on start message. Here the Yang push capability on the OLT showing which XPaths are supported, whatever it's on change supported or periodical supported, and also in which intervals. Then on the 6Win side, we have now also an updated version with the envelope notif and also the Yang library content ID in the subscription started. And here, same also on the notification envelope for both push update and push change update notifications. Now, what was for us a very nice thing to see is basically we just got the first implementation on CBOR named identifiers, and we just open it in Wireshark and just worked out of the box. So that's the overview on MVP1. Green marked what is new compared to the previous IETF 121. On MVP2, we are also steadily progressing. So distributed notif is widely supported. CBOR named identifiers are start coming up. So far, we don't have any DTLS or TLS implementations. And then we also have quite good coverage on change subscriptions and the first implementations on Yang push transport capabilities. That's the hackathon team. A lot of people are participated remotely, or we did preparations for this hackathon. So many thanks for everybody who contributed. That's great work. Any comments, questions, clarifications?
Thank you, Thomas. One observation and one question. So you went from core to virtual router to OLT. Discussing today with one gentleman, he asked me, what about data center?
Yeah, so good point. So far we don't have, but that's one of the next things we want to go.
Thank you. Any other feedback? So thank you very much. It seems that somehow we, oh, Nacho, sorry.
Hi, I'm Nacho from Telefonica. If you go back to this table where you have the vendors, yeah. In this column of open source, is there any open source project that you have already identified, or you are starting something from scratch?
Right. So if I go back in the beginning, I put a little website here. If you go on implementations on this website, you will find the first open source implementations. Right now, I'm just listing the data collections. Today, they are supporting UDP Notif in JSON. However, we are now also working on implementations for the new NMOP network telemetry message format we're describing. And also in the next step, we are working on basically handling the notification messages, not as JSON, but actually as YANG documents.
But just, I'm curious, are these separate components, or are you planning in the long term to have a, let's say, something like the NetOpeer, where you have a full-fledged Netcom server with these new features supported?
That's at the very end our goal there. So at the end, you can go on this website. You have a very easy place to go. You know how to deploy, and you have the solution end to end.
Okay. Thank you.
Great. As mentioned by Ken Watson in NetConf chair just an hour ago, he mentioned something that I like, is that the way to accelerate the specification in the IETF is to get like running code. So I like what you guys are doing with running code. And on top of running code, we're doing also the interrupt testing, a kind of ENC. So very much appreciated. Keep going.
Thanks.
And you got the full chain, right, with the collector as well.
That's correct.
Thank you. Next one is. All right, the next one is the CMAP by Sheriff. So, Sheriff, I will give you the control.
Thank you.
Just 1 second. Okay, up to you.
Yeah, thank you. So just a little bit of brief on this project. So we're trying to model the network basically I'm trying to model a couple of different layers, and the aim is to have multi-layer network and then multi-layer basically CMAP modeled network. And then based on this one, what we tried to do last year is actually trying to do as well. So last year, what we did is we tried to model ISS and OSPF. And we had a small prototype on how to link to external data. And by external data, we mean, you know, it could be anything, but we had like, we started with approach with like configuration and metrics, for example. So last year was a prototype, but this year we are adding more, like we are, you know, evaluating or assessing different options, how to do this actually. So we're giving, we will show this later. Now, this is the lab that we used. So we didn't use the full lab for this scope, for this hackathon. We used a couple of routers there because we wanted to test specific parts. So we were working on the SRv6 on top of ISIS and having the external data, like a couple of examples on the linking the external data. So this one, we were like, the focus was not to put the full lab, but mostly to focus on these two things. Now, to the part where we are linking, so let's start with the part which is linking external data. So we came up with the concept of templates, and templates is more like basically it defines the way how do we get the information, not the information itself. So we didn't want to put the configuration or the metrics or all the external data as part of the map itself, but basically we put the way how to get it. So different things here, but I'll try to keep it a little bit short. So for the templates, we try to do this because we can decouple the information or decouple the templates from the map itself. So you can have the map, you can have the templates, you can, as the network grows, you can add more templates, and then basically templates can have different use cases, and you don't impact that map, but you can add templates for retrieving configurations, retrieving metrics, retrieving whatever. And so this is more scalable, basically, for supporting for when the network grows bigger. The other part is you can define the protocol as well in the template. So you can say, this is, I can get this information using this protocol or that protocol. So it's kind of flexible as well. Now, sorry. Now, this is an example of what the template is. So the left and right, this is the same, this is the same thing. It's just, so you're starting from the left and then continue from the right. So there are different things here, but the important part was like the template type, and on the right, the request. So the template type here is something that you can, like here we have a base and augmentation, example for augmentation, but base could be like config state. We start with something and then we can add other things like metric as well. So it's kind of, we try to get this flexible as possible, but we're trying to have some labeling or some categorization for this template as well, because we don't want to have this very generic as well. So the next one is the right part, which is the request part. So the request is where you can define the request type. So the template type, the previous one was like, what's the data like? What is this data? But this one is, how do we get the data? So this is, can be resconf, netconf, for example. And this is an example basically for the template where you can see, there are like the parameter. So that in this example, there are two requests, restconf, netconf. So you see the first one is restconf, the last one is netconf. I don't know if it's obvious in your screen, but basically you put the XPath and then the XPath has some parameter, and then you just define what are the parameters that are needed for this template. So it's just how do we get the data and the parameters that are needed for this request. Now, we know the template, what is the template. Now, the next thing was like, how do we use it? So there are two options. One of them is, as we see on the left, and the other one is the approach 2. So the first one on the left, we call it approach 1, which is directly augmenting the CMAP with external references. So for each entity type, for each node or link or TP, we actually add external reference. Now in the approach 2, the difference is this is a new Yang, this is a new module, and it's kind of intermediate step between the CMAP and external data. So the approach 1 is directly augmenting the base one, the base model. Approach 2 is having an intermediate layer between the RFC 8345 and its augmentations and the external data. So this is in brief the difference between both of them, and in the rest I'll show more details on the approach 1, more details on the approach 2, and the comparison at the end. So for approach 1, so the first step is a template. So you create the template, basically, it's unrelated to, you can have your own map, but this is like creating the template. So this is how do we get the information, which can be in different, it can be in any of the, it can be inventory, it can be metric, can be configuration, it can be in different places in your network. Now, the second part is you, as usual, like you create your own map. So this is creating the CMap. The difference is here we add the external link to the template as well. So if you see on the left, this is interface and this is the template. So all of these are like ISIS interfaces. They are all, using the same template. And this template, for example, would say, if you wanted to get the interface configuration, interface eye size configuration, do this request. So this is the difference where we built the map before last year, and we, like in this example, here we add the external, we choose which template do we use. And this is basically an example where we choose the template reference, and we actually fill the parameters that are required by the template. So you choose the template, but at the same time you say, okay, this template to be able to run this template, use this parameter ref and parameter value. So this is approach 1. Now approach 2, which is like the separate interface in the middle. Same step. First step is the same. So you start with creating templates. So this is no difference from approach 1. Approach 2 is basically same as we used before. So this is the normal CMap creation. So no changes here. Now the difference is in the last step. So the last step is you have your template created on the left, you have your map created on the right, and then you are adding this layer in the middle, which is, we just call it relation, so that you can choose which template can be chosen for which interface or for which entity in general. This example is just TP, but it's anything. So this is basically the difference between approach 1 and approach 2. Now, this is can try to put some pros and cons for both options so that people can see the differences. And one of the clear differences, I think, is like maybe approach 1 is it's on the base only, so we didn't want to put this as for every augmentation, so we try to put this on the base only. So identifying the right template while building the map can be challenging. There could be potential duplication as well, since this has to be per instance. So for every instance, you add a reference to a template, which can be the same thing. So for 10 interfaces, you have same way of getting the information. So the data could be duplicate. So if the network grows bigger, option 1 will, from our point of view, will be more overhead a little bit and complex. Now the pros for option 1 as well, that it's while you are building already the map, you are just adding small rules or like adding small parts in your implementation, so you can choose which template to use. So the whole coding complexity is less. Now for approach 2, I think approach 2 is more for it gets bigger with bigger network. So it's not very good for a small network, but it gets bigger when the network grows bigger, because you can have, instead of having one-to-one relations, you can have a little bit with some improvement, of course, you can have many-to-many relations or many-to-one relations. So you can have some you can have saving on the data basically, and have reducing the duplication. The pros for approach 2 as well, that we don't need to change the CMap. So if you have the CMap created already, you don't do anything. It's exactly the same. You're just adding this layer in the middle, which is called the relations, so you can connect the templates to your CMap. And identifying the template with this approach 2 would be a lot easier than approach 1. This is kind of in brief, the differences between them. Now, so we finished the first part, which is like how do we link the external information, and these are the two options. Now, this is the second part where we're adding the SRv6. So what we did this time is we added the SRv6 on top of ISIS. So this is basically, in this example, there are two routers, ISIS enabled, and you can see the supporting between the SRv6 layer and the ISIS layer. This is a little bit zoom in on the SRv6 entities. So this is SRv6 network. And SRv6 enable node, which is like it's the ID is basically with the locator of the SRv6 for the segment routing, with the segment routing, yeah. So you can see the locator here is main, and for the other node there will be a different locator. Now this is like kind of the TP, you know, it can be considered as TP, which is like we call it a SRv6 source. We are still looking at this if we can do a better naming for this, but this is our first attempt to do this a little bit connection between ISIS and SRv6. So SRv6 source is kind of the TP basically, and that has the ID is the encapsulation source for the SRv6. Now this is the supporting for node for the node for the network between SRv6 and ISIS. So SRv6 node has supporting ISIS process. SRv6 network has supporting ISIS. And this example was ISIS area, but it can be for different areas, of course. This is a complete view. So this is showing the whole thing with approach one. So this is approach one, so we can show it better on the map, plus SRv6 plus ISIS. So you can see on the top SRv6, down there ISIS, and on the right you can see all of these ISIS interfaces with different templates. So there is one template which is called interface, you know, for the interface configuration, or interface ISS to get the interface ISS configuration, or interface statistics or metrics where you can get the interface states, for example. So this is just an example showing with 3 templates how do we get the interface configuration or statistics for these ISS termination points. This is kind of the graph schema view. If anyone is interested in this, so this is how we the schema of the ISS SRv6 and the relation between both of them. So what we achieved this time. So here we have more, like 2 drafts, and I've put the link there for you. You can find both drafts, or both options basically. What we call approach 1, approach 2. So approach 1 is documentation. Approach 2 is the new module in the intermediate module. So you can see the 2 modules. You can see the example of using both of them in this link. So we added the SRv6 supports for CMAP, but this is just a starting. So we added a couple of nodes. We still have to do the SRv6 segments and links. So this is to be done. So we hope we can continue adding the SRv6, but then we wanted to add more on top layers as well. So we wanted to have BGP layer 3 VPN, for example, and so that we can use we can collect layer 3 VPN service and layer 3 VPN performance modules as well. So we can show the use case more in different layers as well on how to connect to external data. And I think one of the points here is we will try to engage as well with the working group more to evaluate which one is if we have any feedback or comments, which one could be the best approach, whether it's approach 1 or approach 2. So that we can probably proceed with a draft for one of the options.
All right, very good.
And that's it. Yeah.
Thank you, Sheriff. Any quick comment or feedback from the room? Thank you very much, Sheriff. So I have a couple of questions, but I will bring them to the list.
Thank you.
Thank you very much. Good job.
Thank you.
Another network anomaly. Vincenzo, the floor is yours, and I'm going to pass the slide control to you.
Thank you. Thanks, Benoit. And hi, everyone. Cool. I have it. So So this is a slot in which, on behalf of all the authors of these two drafts, I will provide some updates, and I will also share where we are with the hackathon work for the network anomaly detection hackathon. So to start, just a quick refresh about the two documents that I'm presenting an update about. One is the an experiment network anomaly lifecycle document. This document is about defining the lifecycle and some generic data models and APIs that can be used for network anomaly detection post-mortem analysis. And in the scope of this document, we basically defined the life cycle as consisting of three different stages: the detection, the validation, and the refinement. And we defined the role of the label store as the place where the information exchange between these three stages and different actors that work around these three stages basically are persisted. And as part of this draft, we also define a data model, as mentioned, which is defining what is the relevant state. This is linked to also to the terminology draft in a way, because we borrow from there the concept of state and the concept of relevancy, and that's the way we define the relevant state. And the relevant state is defined as a collection of anomalies, and each anomaly is defined as a set of containers. One defines the symptom information, one defines the annotator information, which is the entity which produced the label for the anomaly, and one is the service that is impacted by that anomaly. The second document is the semantic metadata annotation for network anomaly detection. These draft substantially provide a detailed semantic for the let's say for specific for the network connectivity services. And this is defined as an augmentation of the Young data model, which is provided in the other draft. And in particular, the augmentation is provided at the symptom level and at the service level. In particular, for the symptom, the information related to the symptom is structured using three different key elements: the action, the reason, and the cause. And the extension on the service basically defines a set of useful parameters and fields that are needed to identify deterministically which service was which connectivity service is affected by the specific anomaly. In terms of the changes that were done to the documents, mainly we've been focusing on the Young format, and in particular we have been solving some of the key errors that were present in the Young. There are some left, there are a few ones left. Now, to adjust these small errors here, some more significant changes to the Young models are needed, and our plan is to make those changes and validate them via coding. So very likely for the next iteration of the hackathon, these changes will be made and validated. And there are also some other changes we made to the documents, and I just want to highlight probably in the next few slides what are the main changes that have been added to the Young model so far. So in the first place, this is a representation of the relevant state, and I want to mention also that each of the two drafts define a container for the relevant state, but also a notification message, which is sent by the labeler to the postmortem system, or in this case, the label store. And the format for the two is very, very similar. So I'm just showing one for convenience. So one of the things we added this time is the concern score at the relevant state level. We used to have only the concern score at the symptom level, but we realized that there is need for having a global concern score for the whole relevant state. And I will show in a moment in the second part of the presentation, for which is the one related to the hackathon, why that is necessary. Then we also added a field inside the anomaly, which is basically a URL or URI that is a link to the visualization of the anomaly itself. So it provides a way to link the visualization of the anomaly to the anomaly object here. And then the pattern has been changed. This was previously a choice in the Yang. Now it's been defined as an identity ref, and this gives the possibility to the user of the model to augment it and extend it as needed in a way easier manner. The changes to the other draft, substantially, again, these reflect the changes on the Yang model. Substantially, we added the URI in this case as well for the same reason as discussed above. And also we added some fields which are necessary to keep track in the, especially for the, this is for the service augmentation, in particular for the augmentation of the service container. We added some fields which are necessary to identify any changes which are made during maintenance windows or in the network inventory, and these changes turned out to influence the way the network anomaly detection works in some cases. So we want to make sure that this information is persisted together with the label itself, so that the network engineer who reads these labels have this information handy and can use that for the validation as well. So that was all in terms of like the main changes to the documents. In relation to the hackathon, substantially we've been presenting in the past already the work we're doing on Antagonist. Antagonist is a project, it's an open source label store that we are implementing as our vehicle to validate these two drafts as in a running code way. This substantially supports the whole life cycle as it's defined above, and it supports the interaction of multiple users, and where those users can be both humans and algorithmics. And we have been demonstrating this in the past already. We've been validating good part of this with multiple anomaly detection algorithms and techniques. And where we are now is basically we are working on the mapping between the real network incident data and the Yang models that we defined. And I'm going to show a couple of slides later to to provide some details about this. The idea here is to finalize the validation of the Yang models with real network data and finalize the Yang models to make the documents ready for the next stage. Now, in terms of what we plan to do next, so the idea is in fact to validate the label store with to integrate the label store into the network and validate it with real data. So just to provide a quick visual update on this, you might have seen this a version of this diagram with a version of this chart. This is substantially representing one way anomaly detection systems can work, and this is the Cosmos Bright Light. So substantially, you see that there are multiple lines here, and the one above is what represents the max concern score, and the red square is substantially representing the whole relevant state. The whole relevant state, as I was mentioning before, we added a global concern score, which is the line on the top of this diagram, is representing the line on the top of this diagram, which was missing in the model. And then we have and then we have a bunch of symptoms that you can see in the red squares in this slide, and each of them is represented as an item inside the anomaly list that you can see in the model on the left side of the slide. So if you want, this is the way the yesterday Thomas was presenting the post-mortem on the network anomaly detection, and Benoit was asking how does that map with the two drafts in the model, and I think the answer is basically in this slide here. In terms of next steps, what we plan to do, the objective is to get as soon as possible to a final version of these young models. In order to do this, we are substantially working towards preparing antagonists to be integrated into the Swisscom lab and validate the models and the APIs, and this integration work that we started is the beginning of that. We will continue with more mapping exercises and more integration, and ideally we want to provide some further more precise feedback, very likely for the next hackathon, for the next iteration of the IETF. So looking for any feedback on the documents, and also, as you guys know, we are very open for cooperation. So looking for any other operator or anybody else that want to test their network anomaly detection systems or use cases with our antagonist.
Thank you, Vincenzo. Any question, comments in the room? And while people are going to the queue, you mentioned testing with other operators, but I think there is also validating that the internal process of operators doing the postmortem actually is working fine with the draft, the Yang module, and we got all the different parameters. So it's not always code. This is looking at the internal process.
Yes, thanks for the addition. It's absolutely the case, yes.
And one question on my side, so we've got 30 seconds. So you mentioned you need a global concern score, global to something, right? I'm hesitant to use the right term because the terminology fairy could be punishing me. But if you need to have a global concern score, does it mean that you need to have also a global URI? Question mark. Feel free to answer now in the mailing lists, maybe.
Yeah, I will use the 30 seconds to try and reply. So the global concern score, I think I was using some quotes in the slide somewhere. Yeah, I was putting it inside quotes because global means related to the relevant state. So it's an aggregation of the existing concern scores that there are inside the anomalies in the list. For what concern so the second question was about, if you don't mind repeating it.
No, it was only one, global to what? And then if you need to have a global concern score, do you need to have a global URI?
Oh yeah, so
okay, let's take it to the list through to fourth.
Okay.
Thank you, Vincenzo.
Thanks.
All right, the next one is by Michael. You have the slide control in 3 seconds.
Hi, everybody. Wish I was there. Hope you're having a good time. This is relatively quick compared to some of the previous stuff. We did an experiment. So if you remember thinking back to season 1, as they say, in Dublin, we did a RDF version of the Yang schema. What's RDF? It's a set of triples, XML, subject, predicate, and object. It's a graph format for your data. So we were able to transform the Yang schema into essentially a graph. And that worked quite well. During the comments and stuff like that, it was raised, did we use RML, declarative mapping, all of that sort of stuff. And we said we didn't, we did it a different way. So as an experiment, we said for this hackathon, we would try and do it with instance data, and we would try and use the declarative approach. So here's an example. Subject, predicate, and object. You can see here it's iterating through an interface, and it's mapping out the values. This is the format we have. So you've got a mapping file, RML mapping file, and the configuration, or any XML, but in our case, it's an account dump of the device, and we get RDF out, and then we use some Sparkle. Sparkle is the query language for RDF. So we use some Sparkle construct messages. These are adding relationships to add the relationships back to what we did in Dublin. This is the process I just described to you. Here is an example of what we got, and this is for interfaces. You can see there's quite a lot of triples generated, quite a lot of data. Of course, you can filter that out. So for instance, here we've got some very simple filter. Just find me my broadcast interfaces, and you get a much cleaner graph. You can see the code is here. But I would say ultimately, this was not a good approach. And without going through each one of these things, you can see scalability problems, the fact that it's declarative, all of that sort of stuff. And I kind of wanted to bring up maybe just something, kind of a general thing, So some of the comments on the draft that we kind of want to promote is, the lack of tooling, or the poor tooling, or not really, everybody trying to find their way through all of this world, this new RDF knowledge engineering world, especially coming from where we come from. And you may end up kind of searching for what's the right way, what's the what's the real way, what am I missing here? And actually, I suppose in general, with a lot of these graph-based approaches, the tooling is not great. In fact, it is it's quite poor. And this is the same whether you go to the RDF world or you go to property graph world with Neo4j is quite a big company supporting the Cypher and kind of pushing tooling in that direction. But I would say that they are equally as bad. But at the end of the day, it's just XML triples representing what it is that are actually, in some cases, because it's we created a named graph, it's quads. So in a lot of ways, we have a lot of the tools already. There are plenty of tools out there to work in a scalable way with XML, stream processing, and all of the kind of modern software techniques. So we believe that that's really the way forward, and that there is tooling available in the RDF world, but you shouldn't really get too hung up on it. And I suppose that's the main takeaway here. The other is the fact that when pulling in a full device, the number of triples that you're going to generate is going to be huge. So then there's a question of, well, how much of that data do you want to bring in, and how often do you want to do it? So I think all of those are really good points to consider, and some things that we'll probably address in the next hackathon in Madrid.
Very good.
And just finally, these are the people that were involved, and please read our draft.
So we have people in the queue. Nacho.
Hi, Nacho from Telefonica. Hi, Mike.
Hi, Nacho.
So I'm happy to see that you've been trying out the RML language as well. It's good to see this. I wanted to know that the community group within the W3C, that it's developing or defining the RML language is working towards becoming a working group. So it would be beneficial in the future to liaise with them at some
Great.
point. And also, quick question: which RML engine did you use for the experiment?
We actually tried two. There was one in Python and one in Java. We went with the one in Java because it was faster. RML Mapper, I think it was called. You know, it is faster, but the declarative way, you know, this is what I was kind of going with this, is that at the end of the day, it's just XML. And there are so many, you know, Kafka streams and all of these kind of clever things, especially when you're looking at the volume of data that you're going to get from full device config. I think there are better ways to do it.
Okay, thank you.
Thank you. And Lionel.
Yes, hi, Michael. It's Lionel from Orange. Very nice to see your feedback. However, I feel you very hard on your key takeaways about RML. I have plenty of counterexamples of successful deployment of RML on huge size. And I agree with you on difficulties to link the so many subset of data that are required. But I have also experiments, past experiments that shows we can achieve this. Not fully using RML, but we can do it. So I wish we could have some shared discussion also with Nacho, because we have plenty of stuff to, but I don't know how to organize this. So
yeah,
please don't
that
stand
sounds
on
like,
this
a
idea
great thing,
that
and I'd love to hear your feedback, and I'd love to see your experience with it. I suppose my feeling is like the declarative approach is very good for, say, schema mapping. So for instance, actually in reality, we probably got it arseways, right? So we should have been using the declarative approach for the Yang schema versus some streaming approach for the instance data, you know. So I think then it would be potentially the right way to do it. So I'm not hating completely on RML.
Okay. So as a last comment, may I suggest that your first insight about using pre-processing kind to lower your expectations on this, to focus on declarative approach. This is very important to have some provenance tracing of all the data. As soon as you incorporate pre-processing, you break the provenance tracing of the data. So we can discuss this later. Thank you, Michael.
Okay, great. Thank you.
All right, Rob. And by the way, on how to organize this, if you were in the last NMOP meeting, there was a question in the end whether or not we could organize an interim meeting specifically in this topic and receive positive feedback. Rob.
Hi, Michael. Thank you. I think it's really interesting, the problem you're trying to solve here. I think definitely the concept of trying to align these different data sets together and get sort of semantic meaning to them is good. I do wonder whether IF and XML is the right approach there. And to the sort of the point you made in terms of the amount of data and relationships you're generating. So you're suggesting some of the tooling is not working, but I wasn't paying that close attention to know exactly what you're having issues with. And then generating XML, does this mean that things like the query language you're using, like Sparkle, won't work so effectively? Or is this a different stage of the process?
No, it was more the generation of the XML and generating of the triples based on the input data and the scalability, and you know, you're relying, because of the approach using RML. RML uses it's a standard from W3C. And so somebody has agreed a format for defining how you do your mappings and all of that sort of stuff, and then people go off and build an engine. And my feeling, or our feeling on it, like for large scale, pulling in large scale of data, you're better off writing your own thing. It's only XML at the end of the day.
Okay, thank you.
Thank you. So the last session, and we squeeze some time for this. This is 5 minutes presentation on the hackathon result by those students, and you wanted to promote this. So 5 minutes on HTTPS, this is the clicker for you.
Hi everyone. Hi everyone. We are a group of students from undergrad students from a university in India called NITK in Mangalore. And before I start saying anything, I do want to thank Claes and Mohammed for giving us this opportunity, because we were asked during the hackathon. We've already presented this at NetConf, but we're really grateful to be able to present this again at NMOPs. So we'll be talking about implementing HTTPS notifications, Yang-based HTTPS notifications draft, and also while implementing this using Kafka and performing some bandwidth analysis. So this is a quick overview of the draft. It's a configure subscription model. So publisher can learn what a receiver supports in terms of capabilities. And when I say capabilities, I mean what sort of encoding is supported. And those capabilities, once it learns what those capabilities are, it can start sending notifications to the receiver. So ideally, a scenario would be, let's say, some telemetry data. This publisher can start sending notifications in the right encoding format to the receiver. And of course, all of the notification data is in a Yang defined format.
Yeah, so for our implementation, we used Python, and we've implemented the collector as an HTTPS Flask server. So it has two endpoints, the relay notification endpoint and the get capabilities endpoint that Siddharth has already explained. So in addition to this, to store the relay notifications, we've also integrated our collector with Kafka and TSDB. So what happens is once the relay notifications are received by the collector, it sends it to a Kafka topic in the Kafka broker. And then there's a Kafka consumer that runs parallelly, and it consumes data from these topics and pushes it into the TSDB. We've used InfluxDB as our TSDB.
And yes, so what we've done during the hackathon as well is we've performed a sort of analysis of how these different encoding formats would work in under different varying bandwidths. So due to the lack of high-scale infrastructure, we set up virtual network namespaces on our own machine, which would sort of isolate all these processes. We ran the publisher in the publisher namespace. We've spun up 100 concurrent publishers and a collector in the collector namespace, which were connected using virtual Ethernet and a bridge in the host, while we were also collecting the metrics using Prometheus Grafana at the host. So the results we obtained are sort of like this. The green color represents CBOR, orange for XML, and blue for JSON. So here we can see that at lower bandwidths, when network would be sort of the limitation, CBOR gives higher throughput than the JSON, and JSON gives higher throughput than XML, which is sort of expected because CBOR is more concise than JSON, and which is more concise than XML. At higher bandwidths, where network is no longer the limitation, it is the processing speed that would cause the issue. We see a consistent performance of them, like they're all at the maximum processing limitation. So the encoding formats presented in the draft only include JSON and XML, but we'd also included CBOR and proposed a draft on it, which will be talked by Han.
So we have proposed this draft to extend the existing HTTPS notif draft. The notif draft to support CBOR encoding apart from JSON and XML. So from the experiment which we had shown previously, we know that CBOR performs better in low bandwidth networks compared to JSON and XML. So
yeah, so another reason would be the whole idea of HTTPS notif is to maximize transport level interoperability, which would mean we want a variety of encodings. So CBOR is another widely used encoding, which we thought we should include. So in our draft, we made sure to follow the mentions of 9254, which we want to include CBOR using SIDs in keys, which is schema identifiers, as well as names in keys. Siddharth will talk about areas to improve.
Sure. Yeah, we'll wrap it up quickly. Potential issues we face, not potential issues we actually face is a sort of lack of tooling when it comes to CBOR in Yang libraries. There is no existing library, open source, which supports verification and validation for data if the data is in CBOR format against a Yang data model. So that was one issue we faced. So we ended up having to convert the Yang CBOR data into JSON and then validate it, which again would have potentially added some unnecessary overhead in our calculation. There is also no Yang data model. Oh, yeah, it's back. Yeah, there is no Yang data model defined for the notification in the draft itself. So again, this means that we cannot, in case of CBOR, we cannot request for SIDs from IANA, and it also implies that that is something which we have to potentially work on. Part of our future work. We are also thinking of shifting from a network namespace model to say an actual network setup where we can avoid overheads and unknown variables which we don't want to come into our calculations and possibly ruin our numbers. But what we believe is that whatever we do, even irrespective of whether we run it on namespace on a local system or an actual network setup, it should corroborate our existing results. And we also want to look into enabling different kinds of compression. So enable gzip and as a HTTPS header, and let's see how it behaves on low bandwidth networks, high bandwidth networks. So yeah, that's about it. Questions?
So you presented this in NetConf as well. I think it's great you're doing this. So thank you for bringing it here. That's really great. One other suggestion I did make earlier that I just seen from there is I think the libcbor library and Yangson are open source, so you could consider contributing like the CBOR support into those libraries.
Yeah, essentially. There was a suggestion we see from quite a lot of people.
All right, very good. Thank you very much. So we reached the end of the session. Thank you for coming. The last thing I want to say is thank you, Matt, for being a good chair, very well organized. We're going to miss you, but the good news for me is that all my trouble will go to you as AD. So thank you.